Welcome to the third video of portfolio theory. In this video, I will talk about how to calculate the return and risk of a portfolio that has multiple assets. In this case, I will have 4 different assets in a portfolio. And then I will talk about how to find the optimal share of each asset in the portfolio that can maximize the Sharpe ratio using a solver function. So here you can see 4 stocks here, Netflix, Intel, Walmart, and to make things a little bit more interesting, S&P 500. So assuming that you get a share of SPY index fund. Then this data is just like the second video. This data is a weekly data, and what you see is a weekly return from each asset from 2015 to today. And I calculated the average return, so you can see the average function here, and the variance and the standard deviation of each asset. But to be able to calculate the return and risk of this portfolio, we first have to calculate the variance and covariance matrix. The reason why we need a variance covariance matrix is because the variance of a portfolio depends on the share of each asset in the portfolio, risk of each asset in the portfolio, and the covariance between the assets, 2 assets in the portfolio. So in this case, let's say P1, right? P1 is the share of asset 1, which is Netflix, right? So say Netflix, Intel, Walmart, and S&P, right? So these are the shares of each asset in your portfolio, and obviously when you add them up, this will be equal to 1, right? And let's say sigma n is the risk of Netflix. This is risk of Intel, risk of Walmart, risk of S&P 500. And when we square that, then we get the variance, right? Then when you think about the variance of your entire portfolio, variance of your entire portfolio is Pn squared, so share of Netflix squared times the variance of the Netflix plus Pi squared, Pw squared, Ps squared, right? Plus 2 times the share of each asset, Pn. So in case of Pn times Pi times the covariance between the 2 assets, sigma n and I. And we have to do this for all the possible combinations of the 2 assets, right? And for this calculation, it would be really useful if you can calculate a variance covariance matrix. Variance covariance matrix is a matrix, in this case 4x4 matrix, that has information on the variance of each asset and the covariance between 2 assets. So in this case, when we get a variance covariance matrix, it will have the variance of the Netflix asset, covariance of Netflix and the Intel, covariance of Netflix and the Walmart, and the covariance between Netflix and S&P 500. And the second asset will be Intel, so we will have the variance of Intel and the covariance between Intel and the Netflix, and obviously these 2 are the same, and covariance between Intel and the Walmart, and the covariance between Intel and the S&P 500. So we will have this for all 4 assets. So in this case, variance of Walmart will be here, and the variance of S&P 500 will be here, and these will be the covariances. So this is the covariance matrix, and then what we are going to do next is that we will multiply row vector of the weight and the column vector of the weight to this using the linear algebra, and when we do that, we can actually get the variance of the entire portfolio. Okay, so that's the reason why we need to calculate the variance and covariance matrix to calculate the variance of a portfolio. So to generate a variance covariance matrix, we have to go to Data tab here, and at the Data tab we can see the data analysis command here, and we will click this. And when we click this, we can see many different functions here, and out of these functions we will choose covariance and click OK. And in the window you can see the input range and the output option. So in case of input, I will just select all 4 stocks, right? And I will just click this to let Excel know that the first row is the label. And then for the output option, I will click output range here. And for output range, because this is a 4 asset variance covariance matrix, I will select 5x5 table so that we have a label, and click OK. Okay, now we have a variance covariance matrix, and I'm gonna change the format of the numbers so that we can easily compare these numbers to the variance that we calculated. So we can see that this is the variance of the Netflix stock, and it is equal to the variance that we calculated. And we can see these variance numbers perfectly match with the variance number that we previously calculated. Okay, and this is the covariance between the Netflix and the Intel, and this is the covariance between Netflix and the Walmart and S&P 500 then. Okay, so what we have to do is that we have to fill in the rest, because we know that the covariance between Intel and Netflix is equal to covariance between Netflix and Intel, so this is equal to this one, and we will do the same for the rest. Okay, so now we are all set with the variance and covariance matrix. Then the next thing that we need is the weight of each asset, which is the share of each asset in your portfolio. So I will say this is weight. And for starters, I will just type in any dummy weight. So I will say 10%, 20%, 30%, 40%. And obviously the sum of this will be, and will have to be, equal to 100%, right? Now we are ready to calculate the portfolio return and the portfolio risk. To calculate the portfolio return, okay, we need to use a function called sum product. So sum product allows us to calculate a product of 2 different lines of the data. Okay, so when you type in sum product and open up a parenthesis, you will see the Excel asking for array of numbers, right? So the first number that we need is the rate of return of each asset, because the rate of return of a portfolio is the weighted average of the return of each asset. So we need the rate of return information first. Then we will multiply the weights to each rate of return, right? So we are going to multiply the weight. So the second array of numbers will be the weight. But in this case, because the format of the weight is different from the format of the return, right? So return is a row vector and weight is a column vector. So we are going to transpose the weight. Oops, not this one. So that the format matches, and so that the Excel can calculate this properly. Then press enter, and now we can calculate. Now we can see the rate of return of your portfolio given the weight of each asset, right? Then the next step is to calculate the portfolio risk, right? In case of the portfolio risk, as I told you before, we have to use a linear algebra. So we have to use the matrix multiplication. For that, we have to use a new function called MULT. Oops, T. So this is a matrix multiplication. And because we have to actually get a product of a row vector, variance covariance matrix, and the column vector, right? The first thing that we have to do is identify the row vector of weight, but the weight vector that we have is a column vector, so we are going to transpose it again. So we are going to transpose the column vector of weights into a row vector. And then the second set of second array of number is the product of variance covariance matrix, which is this. Oh, before that, because we will have to do a matrix multiplication again, MULT. So we are going to multiply the variance covariance matrix to the column vector of weight, because it's a 4x4 matrix times 4x1 vector. What we will get is a 4x1 vector. And we are going to multiply 1x4 vector with the 4x1 vector, which will give us a single number, right? So that's what we are doing here. And that single number will be the variance of your entire portfolio. Now, before we press enter, we have to remember that this matrix multiplication is an array function. So whenever you use an array function, instead of pressing enter, you have to use Control-Shift-Enter. Okay. Oh, there was a typo. Okay. So when we do that, we can get the variance of your portfolio. And I will turn this into a percentage number. Okay. And again, remember that this was a variance. So if you want to calculate portfolio standard deviation, then the standard deviation is just the square root of this. So we can now easily compare this to the risk of other assets that we calculated. So when we create a portfolio of these four assets using this weight, the portfolio return is about 0.3%, which is slightly higher than the return of the Walmart. And because we have a diversified portfolio and these assets are not strongly correlated, as we can see from here, standard deviation, the risk of the portfolio is actually smaller than the risk of the Walmart. Okay, so we create a portfolio that has a higher return than the Walmart asset, at the same time safer than the Walmart stock. Okay, now The next step is to think about optimizing the share of each asset in your portfolio to achieve whatever you want to achieve. So for example, if you want to create a portfolio of these 4 assets that can minimize the risk of your entire portfolio, right? For that, we can actually use the solver function. So we can go to data again and solver, right? Okay. Then let's say we want to minimize the portfolio risk, right? So we will choose the portfolio risk and we want to minimize it. And we want to achieve that by changing the values of the weight, right? By changing the share of each asset in your portfolio. Then we can add some constraints, right? So I'm going to delete all this. Okay. Then I will add a new constraint. So the constraints that we are going to add is first, the sum of all the weights, right? The sum of all the weights is equal to 1. Okay. Then the second one is we want to make sure that the weight of each asset is larger than or equal to 0. And this means that there is no short sale possibility of any of these assets. Okay. So the same is true for the Intel asset. Same. And for the Walmart. And for S&P 500. Okay. Then what you see here is that here. Okay. What you see here is that now we are minimizing the portfolio standard deviation by changing the weight, right, which is listed in L7 to L10, and we are setting up a constraint that the sum of the weight is equal to 1 and the weight of each asset has to be either 0 or positive. Okay, then click solve. Then Excel will solve the problem, and according to Excel's calculation, if we really want to minimize the risk without paying attention to the return, then the investor should spend 63% of his or her money on the S&P 500 and 37% on the Walmart. Okay, but in most cases, investors do not simply want to minimize the risk, right? They want to maximize the return given the risk, right? And in the last class, we learned about the Sharpe ratio, right? And to be able to calculate the Sharpe ratio, we have to introduce a risk-free asset. And there has to be a rate of return on that risk-free asset, which is called as risk-free rate, right? And we usually use a T-bill for that. And for this case, let's assume that the risk-free rate is a 0.05%. Okay. Then the Sharpe ratio is the risk premium of your portfolio, which is the rate of return of your portfolio over the risk-free rate. So rate of return of your portfolio minus the risk-free rate divided by the standard deviation of your portfolio, right? And I told you that this captures the risk premium per the unit of risk that you have taken. Okay. Now, what I'm going to do next is go back to the solver function. So instead of finding the weight of share of each asset that can minimize the risk, I will try to find the weight of each asset, the optimal portfolio that can maximize the Sharpe ratio. Okay, so we want to maximize this using the same weight that we just same information, right? The weight that we highlighted. And in case of the constraint, we are using exactly the same constraint, that the sum of all the weights is equal to 1, and each asset has to has the share of either 0 or positive. Okay, then click OK. Then Excel will solve the problem. So according to Excel, right, if we really want to maximize the Sharpe ratio, then the share of each asset has to be 42% Netflix, 17% Intel, 41% Walmart. And the S&P 500 should be 0. Okay, and in that case, the Sharpe ratio will be 0.142. Now I will show you how to create a graph of efficient portfolio frontier that you can generate out of these 4 stocks. Creating a efficient portfolio frontier graph is, when you have 4 assets, is a whole lot more complicated than doing the same thing using 2 assets. So to create a chart, we have to actually go back to the solver. Okay, we have to go back to the solver here and find the weight combination that minimizes the risk of the entire portfolio. So I will choose this, the risk of your portfolio, and I will minimize this using the same weight. Okay, then we go back to this case, right? So 63% of our money is invested in S&P 500 and 37% in the Walmart. And in that case, the portfolio risk is 0.04 and the standard deviation is 2.11, and the portfolio return is 0.19%. The reason why this is important is because to create an efficient portfolio frontier, now you have to change the return of your portfolio one by one and find a combination of the weights that can minimize the risk of the entire portfolio given the rate of return, right? So to help you understand, think about what the efficient portfolio frontier is. So we have S&P 500 here. So this is S&P 500. And then there is the Walmart here. Then there's Intel. And there's Netflix. Right? So what the efficient portfolio frontier does is that it will calculate the variance and covariance between these 2 assets and change the weight of each asset and create a return and risk profile of that portfolio. And it'll do that for each of these assets. And then combination of these portfolios, right? And then it'll connect the most left and upper boundaries of these portfolio frontiers. Right? So this red part becomes the efficient portfolio frontier. So this is the best possible combination of return and the risk that you can create by changing the weight of each asset in the portfolio. Okay, so what it means is that we will need to set the rate of return for a certain level and then find the combination of the weight that can minimize the risk, right? So that's what we are going to do here, right? So the first thing that we have to do is we need to identify the portfolio return at which the risk is minimized. The reason is because after a certain point, the shape of your efficient portfolio frontier will have a U shape. So it will have a shape like this, right? So at this point, according to the calculation that we have made, the rate of return is 9.19%, right? So if the rate of return is greater than 0.19%, then it has a positive slope. If the rate of return is less than 0.19%, then this efficient portfolio frontier will have a negative slope, right? So for each case, the function that we use to find the optimal points, right, has to be different. So that's the reason why we have to identify this point. And it'll become clear, exactly what I mean as we move along. And one more thing that we need to think about is the potential range of the expected rate of return of the portfolio, right? So out of that 4 assets that we have, the one that has the lowest return is the S&P 500, and that is, say, here, right? And that has the return of 0.14%, right? And one that has the highest return, that will be the the right tip, right uppermost tip of this efficient portfolio frontier will be the Netflix, and this will be the S&P 500. And in case of the Netflix, the rate of return is a 0.81%. So the possible range of the rate of return of our portfolio is between 0.14 and 0.81, right? So if we want to create a chart, a graph, and want to create, say, 10 different points on that graph, then using this as a guidance to think about, where the points should be. Okay. All right. So now I will type in the information that we need for the graph here. So we need the portfolio return and the risk and the standard deviation, right? And we know that the minimum variance combination of the return, risk, and the standard deviation is right here, right? So I will just copy this and paste it here. But when I paste it here, I don't want to keep the functions. I just want to keep the values. So when you want to do paste special, the shortcut is Control-Alt-V. And if you want to choose values, press V again. So Control-Alt-V, V will give you the value paste. Okay. Then the next thing that I want is that now I will increase the expected return of the portfolio by 0.1, right? Because I need to have about 10 different data points to create a chart. So I will start from 0.19%, which is the minimum, and then gradually increase the point rate of return until I reach the highest point, which is the 0.81 of the Netflix. So what I will do is that I will go to the solver function again. Okay, so I will go to data, solver. Okay, then I will add one more constraint, and the constraint is the portfolio return has to be less than, or has to be greater than or equal to 0.3%. Okay, because 0.19 is about 0.2, so I will just increase that by about 0.1, right? Then, given the expected shape of the efficient portfolio frontier, most likely what will happen is that the risk of the portfolio is minimized when the rate of return is actually equal to 0.3%. Okay, so I will click add. Okay, then you can see that that constraint is added. Then I will click solve. Okay, then Excel will solve the problem. Now you can see the weight has changed, right? And as expected, oh, make it bigger. Now you can see the weight has changed, right? And as expected, the portfolio return is 0.3%. And in that case, the portfolio risk is a 2.3%. So I'll just copy this again, and I will paste it as a value. Again, Ctrl-Alt-V, V, right? And we have to do this for many times until we get to the highest possible value, which is the rate of return of the Netflix. So go to the solver again. And now I will change this value, change this constraint. No, cancel. Go to the solver. I will change this constraint from 0.3 to 0.4. Then this will give us the optimal combination of the each share, each stock that can minimize the risk while holding the rate of return at 0.4%. Okay. Click OK. Now the portfolio return is 0.4%, and this is the risk at that point. So I will just copy this, paste the value again. Okay. And as I told you, we have to do this many times. And for the sake of time, I will just do this by myself and add the data points. Now we have the data points of the efficient portfolio frontier for the rate of return from 0.19%, 0.3, 0.4, 0.5, 0.6, 0.7. Then we know that the uppermost point of that efficient portfolio frontier must be the rate of return and the risk combination of the Netflix stock, right? Because Netflix has the rate of return of 0.81, and there is no other stock that in my portfolio that has higher return than the Netflix. So I will simply copy this, right, and paste it here, because this will be the uppermost point of the efficient portfolio frontier, and the lowermost point, the lowest point of the efficient portfolio frontier should be the S&P 500. So I will copy this again and paste the value. Okay. Then now we have all the data points that we need to create the efficient portfolio frontier of these four assets. So what I will do is I will go to Insert and Chart. And just like the two asset case, I will choose the scatter plot with the smooth lines. Okay. And I will move it here. Okay. And go to Select Data. And in the data, I will click this and the series X value. So, in case of the efficient portfolio frontier, we always put the risk